Okay.
Very good.
Well, welcome again. My name's Qian. There's Eric right there. We're the sub-project leads. So today we'll just have a quick updates on both of the sub-project. So within the sub-project, we have two work streams, DCSM and RunBMC. The idea of DCSM is placing the common server management, security, and control features on a common form factor daughter card versus on the motherboard. Similarly, RunBMC, the idea is to just put the BMC features on the module and not the security and IOs and etc. So starting with DCSM, this past year, the work group worked on the 2.1 base specification. This is a list of contributors. We have 19 in total right here. And congratulations to everyone here participated and contributed. We have the 2.1 approved by the SEs and uploaded to the contribution portal last week. So as soon as the FSA is signed, it'll be available to download from the contribution portal. Okay, so what's in the DCSM package? We have a base specification. That's the 2.1 base spec, and we have the LVDS specification, and we have the DCSCI. This is the pin list spreadsheet that goes with the 2.1 package. The bottom of this page is the link to our wiki where you can find the latest documentation on all these three. So in the base spec, we introduced two vertical form factors in 2.1. The minimum chassis height for both of these is in a 2U chassis. So the benefits of the VFF is it bridges the gap between the HPM and the rear of the chassis. So you could either shorten the chassis length in your design or increase, you have additional board design space in your baseboard and on the DCSM. So the long version of this we designed it so that it's the same as PCIe full height, half length, adapter depth, and the short version matches the OCP NIC 3 depth. So we enhanced the FRU content set requirements in the 2.1. The FRU section is for the HPM FRU multi-record section. So this is not the SCM FRU. This goes in the HPM FRU. We made some clarifications on the JTAG signal naming, relax the early power state in some of the interfaces so you can bring them up earlier during the boot process. We added the SGPIO timing requirements. This is same as that is specified in the DCMHS MPIC specification. So in our spec, we will say that you should follow the latest MPIC specs. So all the modular design components have the same requirements. Okay, so here's a visual for the VFF form factor. It's roughly 200 millimeters in length. This is the short version. And here's a long version. The height is the same. It's roughly 260 millimeters. Okay, the pin list. Minimum change here, we added alternate functions in some of the pins to support 2 TPMs for dual node. And same with the SGMI for dual node, we selected some pins as alternate functions for SGMI. For JTAG, we switched the TDO and TDI signal names. The direction did not change, so if you have already designed a 2.0 DCSM, there's no conflict between the 2.1 and 2.0. It's just the name change to better match the industry use cases. And again, the power state change on some of the interfaces like I2C, so you can bring them earlier during standby, for instance, as opposed to during S5. Okay, LTPI. So as LTPI being implemented on various devices, we discovered some interoperability issues. So these changes are basically enhancements to make the spec more easier for improving the interoperability between devices and implementations. So we have some clarifications on the UART tunneling. We enable echo support by default versus optional. We fixed the UART enabling, bit alignment, and a typo in the UART 0, and some clarification on the CRC algorithm. So previously it wasn't defined, so different companies were implementing it differently. No inversion reflection versus inversion reflection, so the group decided on no inversion. Clarification on the total number of normal latency GPIOs, and then lastly, increase the timeout for the advertised frame. Okay. So that was all base specification. So this ongoing effort is to improve compatibility between, say, if you just design to the base spec, company A, HPM, is not likely to work with company B's SCM. So this work here is to define a type, type that we call it HPM Common Circuit Type 1 design. Hopefully this will work for majority of the SCMs out there on the market. In this, we'll define one DCSM managing one HPM with one host domain, meaning this is a single node DCSM. And so you could have either 1, 2, or 4 socket CPUs on this one, on the HPM. So the goal is to guarantee hardware interoperability between HPM. If you have a Type 1 HPM, it should be interoperable with Type 1 SCM, and provide basis for achieving firmware, BIOS, and programmable logic interoperability. So we're moving up the stack from just the base electrical mechanical spec and up the stack to the firmware level. So this is work in progress. We have the 0.5 version of this on our wiki, and so is the pin list. We welcome any feedback, suggestion anyone has, and here, this is the mailing list for DCSM, so you can reach us through this link. So this past year has been busy for a lot of the community. These are the contributions since the last summit. We have 2 reference designs from AMD, a vertical form factor design and a horizontal for DCSM 1.0. We have a reference LTPI implementation from Intel for DCSM 2 and later, so this should be device agnostic, so you could run this on any FPGA. A DCSM 2 reference design from Cloudflare, Lenovo. Again, the links are the contribution portal links that goes with each of the contribution. And a DCSM 2.0 from Axiato. And most excitingly, we have 2 marketplace products. These are the products you can order off the shelf from the OCP marketplace. One from Qian and one from Pegatron. So we welcome you to go take a look on the marketplace. Okay, moving on to RunBMC. So the team has been working on the RunBMC 1.5 specification. The objective here is to keep it backwards compatible with 1.4.1 spec, meaning no electrical, mechanical changes, just pinout changes. And adding, to do that, we did that to add support to the latest generation of server platforms and the latest BMC SoCs. We just released the preliminary spec on our wiki just a couple weeks ago. So this is the different mailing list link to reach our RunBMC team. If you have any feedbacks, please review the specification and provide any feedbacks and comments. We'd like to hear from you. Okay. So the detailed changes on the RunBMC pinout, we added DisplayPort, a dedicated power good signal, a dedicated BMC core reset for attestation, genericize the reset signal, and most excitingly, we added 6 I3C channels. And here's a detailed pin list for reference. We're not going to go through all of this. Okay, contributions. Intel contributed the Cyclone 5 RunBMC reference design. This is the FPGA-based RunBMC design. And so the top bullet above is the reference design related schematics, RTL associated with this reference design. And the bottom bullet is we have, Intel has contributed this to the marketplace, so you can order this from the OCP marketplace, and it has been OCP accepted. Okay, call to action. We welcome you to join our community. For DCSM, we have a spreadsheet to collect any feedbacks from the community, likes, dislikes, or wish list, what you like to see going forward, what are your concerns, what do the future of the DCSM. And we ask you to review the RunBMC specification and love to hear your feedbacks. Project site for meeting calendars. And then lastly, the wiki is where you can find the latest and greatest of everything. For those of you who haven't seen this already, I have an example of, just in comparison, a DCSM. This is a 2.0 form factor, and the RunBMC larger RunBMC form factor. So this is a kind of a comparison in dimension. I don't know if you can tell, this little guy is the RunBMC, the bigger one is the SCM. So that's what it looks like. And how am I doing on time? Any questions? Oh, 7 minutes? Wow, I went through that quick. No questions? I think done? Good?
I have a question.
Oh, somebody has a question.
This is JQ from Cloudflare. The question is for the DCSM specification for specifically like type 1 HPM. Is there plans to extend that to other types in the future as well? Is type 1 what the entire industry should be designing towards?
Like the name says, it's type 1. You're welcome to contribute and join us and define type 2, 3, and etc. So type 1, we hope it to be to service majority of the servers out there in the industry, but of course there are special cases where you will need a different type.
Thank you.
All right, no other questions. Thank you very much.